Hello students, welcome to the academia. Today our topic is action potential. In our last video I have discussed about the RMP, that is resting membrane potential, and a bit about action potential. Now in today's video I will discuss about the definition, the origin, the phases, and about the graphical representation of the action potential. Okay, so stay with us. The brief sequence of changes which occur in the membrane potential, I have discussed already. Following excitation is called action potential. So what is that? What is action potential? That is the brief sequence Okay, so excitable cells, basically the excitable cells are the nerve and muscle cells. So the excitable cells like nerve cells, then muscle cells, generate action potentials when they are stimulated by a change in membrane potential. Okay, so it is due to the disturbance in the ionic equilibrium across the receptive zone of the cell membrane. Okay, that is changes in the conduction of ions across the cell membrane. In the RMP, resting membrane potential, I have already discussed that inside of the cell during the resting condition is minus 70 millivolt. And when the distribution of ion occurred through the ion channels, the sodium come inside the cell and there is depolarization occur. So action potential is divided into some phases. So the phases are first of all, number one, during a resting stage. Okay, so resting state, this state is also known as polarized state. Okay, the inside of a nerve is negative. Okay, and the outside of the nerve is positive, or the inside of the cell is negative and outside of the cell is positive basically. So the resting membrane potential in most of the neuron is minus. The RMP in neurons or resting cells, okay, RMP resting membrane potential or in neurons, what? It is 70 millivolt. Okay. So in the next phase, when we apply the stimulus, okay, or when the cell is stimulated, so there is a brief irregular deflection of the baseline. When I show you the diagram, you can easily understand that the stimulus artifact. Okay, and this is due to the current leakage from the stimulating electrode to the recording electrode, and it marks the point of stimulus. The stimulus artifact is followed by a isopotential interval or latent period. So it is followed by latent period, which ends with the next potential change. So what is that? It corresponds to the time it takes the impulse to travel along the axon from the site of stimulation to the recording electrode. So when we record action potential, then this phase is very much important. Next, moving to the third phase. The first manifestation of the approaching impulse is beginning of depolarization. So, or reverse polarization of membrane, or we can say it is a reverse polarization of membrane. Depolarization means what? In the resting state, the cell is in the polarized state. That is, inside the cell there is minus 70 millivolt. So depolarization means what? It means reduction in the membrane potential. So what does it mean? It means the reduction of the membrane potential from its negative value towards 0. From its negative value towards 0. Okay. So it goes from minus 70 to minus 55, minus 40, minus 25, and gradually it goes. So what which one is the threshold potential? Which one is the spike potential? Then it will come later on. So after the depolarization stage, the after an initial 15 millivolt of depolarization. So from minus 70, when it goes to minus 60 and then minus 55, that is the initial 15 millivolt of depolarization, the rate of depolarization increases. So number 4 state is what? It is the firing level. Okay. So after initial 15 MV of depolarization, so the point is minus 55. So the rate of depolarization increases, and the point at which this change in rate occurs is called the firing level. So this is the firing level. Okay. What does it mean? So keep this in mind. The firing level is very much important because it is also known as threshold excitation. And when it occurred actually in minus 55 millivolt. And the point at which this change in rate occurs is called the firing level. So from where we get the spike. Okay. Okay. So after that, this firing continues, and it passes 0 potential from minus 55 to minus 40, minus 25, minus 10, that it reaches 0 potential, and to the approx it shoots to plus 35 MV. Okay. So this is the phase, and then we get the spike potential. The next phase is repolarization. Repolarization means the reverse, it goes to negativity and falls rapidly towards the resting level. So repolarization means again it becomes negative. Okay. So in the diagram you can easily understand the action potential curve, okay, of a neuron, and you see this is the stimulus artifact. So this is stimulus artifact. Okay, and which one is the latent period? Can you tell? So this is the LP. LP is latent period. So this is the time and this is the MV. So can anyone guess the firing level? Which one is the firing level? So the firing level is this. So this is the firing level. Next, we can see the depolarization wave. So this is the depolarization. And this one is the spike potential at plus 35. It overshoots and we get a spike potential. Then after this, there is the repolarization. That is getting back to again in the negative. And this area, that is the after depolarization, it is called after depolarization. And the remaining area is after hyperpolarization. Okay, so this is after hyperpolarization. And then again this is the RMP, that is you know all, this is the resting membrane potential. Again it achieve the RMP. So which part is the overshoot? So this part is the overshoot. And this area is the complete depolarization. So this is the basic action potential graph, and after giving the stimulation there is potential and generation of action potential. So all of you just practice the diagram and also the phases of this curve. So the next phase, that is when repolarization is about 70% completed. So in the curve we have already seen the rate of repolarization then decreases, and again it try to approach the resting level slowly. Okay, so the sharp rise and the rapid fall. If you want to get a proper curve, then we get a spike. Okay, so and this sharp rise and rapid fall actually called spike potential. And the slower fall at the end of the process is the after depolarization. So in the graph curve I have already shown you. Next point is after hyperpolarization. So after depolarization, the next one is the after hyperpolarization. What does it mean? So after reaching the previous resting level, it found the tracing becomes slightly more negative, and that's why the curve goes down more negative than its resting value for quite some time. This small but prolonged increase in the membrane potential is called after hyperpolarization. So can understand the hyperpolarization after hyperpolarization. So it is a small but prolonged increase in the membrane potential. Okay, so after depolarization lasts for approximately 4 milliseconds only, while after hyperpolarization is 1 to 2 millivolt in amplitude. So this is approximately 1 to 2 millivolt in amplitude. Okay, and lasts for approximately 35 to 40 milliseconds. So it lasts for 35 to 40 milliseconds. What about after depolarization lasts for 4 milliseconds? Okay, these potentials represent recovery process in the neurons. If the nerve has been conducting repeatedly for a long time, the after hyperpolarization is usually quite large. Depolarization decreases the stability of the membrane, while hyperpolarization increases the stability, because then it back to the resting membrane potential. So the size and duration of the action potential, it varies. So whatever potential is generated, it varies from tissue to tissue. It is not that all the time same size action potential curve we get, or the curve is of same duration. The duration of action potential in a mammalian axon is not more than a few milliseconds, but in case of cardiac muscle fiber, it is approximately 200 to 300 milliseconds. So keep this in mind. So this is the thing, and it is quite interesting also due to the structure of the cardiac muscle, and that's why our heart pumps continuously throughout our life. So this is about the action potential, the phases, the curves, and in my next video I will discuss about the ionic basis, that is how what is the mechanism of development of the potential of the phases. Okay, so if you have any query or question regarding the introduction, so you can ask or can comment in the comment box. Thank you so much.